How are we going to understand the origins of our solar system from a spacecraft? Hi, and welcome back to Science Wrap, the show where we feed you the tastiest new research from the world of science, all wrapped up in an easy-to-digest package. My name's Miriam, PhD and science lover. So this week I thought I'd do a little special all about Juno, the spacecraft. And I know what you're thinking, Miriam, you're so behind the planetary 8-ball. This happened like a week ago. Yes, but it's very soon that scientists are going to start getting data back from the spacecraft. So before then, I thought I'd do a little bit of a wrap-up about it. Many of us last week would have seen the images of NASA scientists cheering and celebrating that Juno had sent radio signals back to Earth.
All stations on Juno Accord, we have the tone for burn cutoff on Delta B. Grazie move Juno. Welcome to Jupiter.
But what does this mission actually mean in terms of science, in terms of our understanding of how planets formed, and for future space exploration? In today's episode, I wanted to delve a little deeper into the Juno mission, whose primary purpose is to understand the evolution and origin of Jupiter. Okay, so the first question might be, why Jupiter? For one, Jupiter is shrouded in mystery, quite literally. Its atmosphere is so thick that no one really knows what lies beneath its colourful bands. This is actually why the spacecraft is called Juno. In Roman mythology, the goddess Juno was actually able to peer through the cloudy veil of Jupiter and reveal the mischief that he was up to. Goal number one then is mapping the atmosphere's composition, temperature, clouds, and patterns of movement down deeper than ever before. Apart from the allure of the mysterious, Jupiter is actually a really excellent model for studying the origin of our solar system and the origin of the planets within our solar system. And this is really the crux of the mission. Jupiter is a massive planet, primarily made up of the gases hydrogen and helium. It's thought that Jupiter is one of the first planets to form in our solar system, after the formation of the Sun. The current theory of planet formation is called the nebula hypothesis. It proposes that giant, dense clouds of molecular hydrogen start to clump together, rotate, and eventually form a flat disk with a star at the center and a ring of gases, dust, and rocks around it. The ring of gases and dust later form our planets, the first and biggest of which was Jupiter. The next question then is, how do you get from a nebula to a planet? Again, Jupiter is key for answering this question. That's because it's maintained its original composition. Unlike Earth, it has undergone quite a few changes since its formation. In that way, Jupiter is like a snapshot in time, a looking glass into the origins of our solar system. The final question then, and this kind of ties everything together, is what is Juno actually measuring? A lot of planet formation has to do with gravity. Therefore, Juno is going to be measuring Jupiter's magnetic and gravitational fields, and trying to understand how its magnetosphere affects its atmosphere. The first data is expected to come out on August 27th, when Juno is close to Jupiter again. Currently, Juno is sitting in an orbit around Jupiter and being constantly propelled by its gravity, just like a moon or other satellite. In the meantime, while we wait for data, we'll sit here on Earth with bated breath. Okay, that's a wrap on the background of the Juno mission. If you've got any other specific questions, feel free to leave them in the comments below and I'll try and answer them. In the meantime, don't forget to subscribe and like the Facebook page. And as always, thanks very much for watching. Bye!